Our next topic will be the separation of core loss. So the core loss of a transformer depends upon the frequency and the maximum flux density when the volume and the thickness of the core laminations are given. The core loss is made up of two parts, which is the hysteresis loss and the eddy current loss. So the total core loss is given by the sum of hysteresis loss and the eddy current loss. If you carry out two experiments using two different frequencies but the same maximum flux density, we should be able to find the constants and hence calculate the hysteresis and eddy current losses separately. So here, the core loss is equal to the eddy current loss plus the hysteresis loss, where your eddy current loss, PE, is equal to our constant, KE, times the frequency times the maximum flux density squared, or KE prime multiplied by the supply voltage squared. So we can calculate KE if the frequency and also the eddy current loss is given, provided that the maximum flux density of eddy current loss and hysteresis loss are the same. So eddy current hysteresis loss is equal to KH times the frequency times the maximum flux density raised to 1.6, or KH prime multiplied by the generated voltage or the supply voltage raised to 1.6 divided by F raised to 0.6, where your KE, KH, KE prime, KH prime is the proportionality constant, AG is the supply voltage, and beta M is the maximum flux density in Tesla. Example. In a transformer, the core loss is found to be 52 watts at 40 Hz and 90 watts at 60 Hz, measured at the same peak flux density. Compute the hysteresis and eddy current losses at 50 Hz. So we have core loss 1 equal to 52 watts at frequency 1 equal to 40 watts. PC2 equal to 90 watts at F2 equal to 60 watts. So these two core losses have the same flux density. Compute for the eddy power loss, eddy current power loss, and hysteresis loss at frequency equal to 50 Hz. In our formula, the core loss is equal to the constant, eddy current constant, multiplied by the frequency squared plus hysteresis constant multiplied by the frequency. If we will simplify this equation, we will get PC1 divided by F equal to KEF plus KH. And then we will get the PC1 equal to 52 watts. Our F1 is 40 Hz, equal to our frequency is 40 Hz times KE plus KH. 52 divided by 40 is 1.3 equal to 40 KE plus KH. So we will have our first equation, KH is equal to 1.3 minus 40 KE. In our second condition, PC2 is equal to KE F2 squared plus KH F2. PC2 is 90 watts divided by our frequency. So if we simplify this equation, we will get the same equation here. The only difference is that we use PC2 and F2 here. So 90 divided by 60 equal to 60 KE plus KH. That is our equation 2. For us to get the PE and PH, we will solve first the KE and KH. So we will substitute equation 1 in equation 2. So 90 divided by 60 is 1.5 equal to 60 KE plus 1.3 minus 40 KE. Therefore, we will get KE is equal to 0.01. Solving for KH, we'll substitute KE in our equation 1. So 1.3 minus 40 times 0.01. So KH is 0.9. We will now get the PE and PH at 50 Hertz. So at 50 Hertz, PE is equal to, so the formula for PE is KE F squared equal to KE is 0.01. F now is 50 Hertz squared. So the value of our eddy current loss is equal to 25 watts. And hysteresis loss, PH is equal to KHF1. KHFF, not F1. F. KH is 0.9 times 50. That is 45 watts. So if we finally get the core loss of these parameters at 50 Hertz, it will be equal to PE plus PH, 25 plus 45 watts. So that is equal to 70 watts. So ito yung answers. Second example. A transformer has a core loss of 160 watts when the primary is connected to a 230 volts 60 cycle source. When the transformer is served by a 40 cycle supply, the impressed voltage is reduced to 40/60 of 230, or that is 153 volts, to maintain the same flux density as an 60 cycle. Under this condition, the core loss was found to be 96 watts. Calculate the 60 cycle hysteresis and eddy current loss. For our first condition, we have copper loss. PC1 is equal to 160 watts and its frequency is at 60 cycle source. So the supply voltage at this core loss is 230 volts. While the PC2, which is the core loss at condition 2, is equal to 96 watts. At second frequency is 40 Hertz, 40 cycle supply. E2 is equal to 153 volts. So we will solve the hysteresis and eddy current loss, the PE and the PH. So our formula a while ago is equal to PE is equal to KE, the proportionality constant of eddy current loss, multiplied by EG2 squared, EG squared. While the hysteresis is KH prime EG raised to 1.6 divided by F raised to 0.6. So for PC1 at 230 volts and 60 Hertz, we have PC1 is equal to 160 equal to KE 230 squared plus KH times 230 raised to 1.6 divided by 60 raised to 0.6. 160 is equal to 52,900 KE plus 515.079 KH. So our equation 1 will be Ke is equal to 160 minus 515.079 kH divided by 52,900. For PC2, we have 96 watts equal to 153 squared Ke plus Kh times 153 raised to 1.6 divided by 40 raised to 0.6. 96 is equal to 23,409 Ke plus 342.192 Kh. That is 96 equal to, so this is our equation 2 now. We will substitute equation 1 in equation 2. So that is 96 equal to 2,000 or 23,409 multiplied by the value of Ke, that is 160 minus 515.079 Kh divided by 52,900 plus 342.192 Kh. We will multiply both sides by 52,900. We'll end up getting Kh is equal to 0.2205, while Ke, we'll substitute this one in our equation 1 para makuha yung Ke. So Ke is equal to 8.774 times 10 raised to negative 4. For us to get the pH and Pe, just substitute the value of Kh here. This one. And also, the value of Ke, substitute nyo lang dito and then you will get your Pe and pH.